Imagine trying to separate facts from opinions in thousands of multilingual news articles, sentence by sentence, with no surrounding context to guide you. This precise challenge drives the need for automated subjectivity detection in our information-rich world. Building on this challenge, the researchers tackled a specific classification task that's crucial for fact-checking workflows. The goal is distinguishing personal opinions and sarcasm from factual statements, but with the added complexity of working across multiple languages and dealing with imbalanced data. Let's examine how the team approached this multifaceted problem. The key insight driving this work is that subjective sentences often carry stronger emotional signals than objective ones. The researchers hypothesized that explicitly providing sentiment information to transformer models could improve their ability to detect subjectivity. This comparison highlights the core architectural difference in their approach. Rather than relying solely on the transformer to learn sentiment patterns implicitly, they provide explicit positive, neutral, and negative sentiment probabilities as additional input features. Moving to implementation specifics, the team built their system using proven transformer architectures. They chose a multilingual sentiment model trained on Twitter data, acknowledging the domain mismatch with news, but prioritizing broad language coverage. The training approach required careful consideration of the multilingual and class imbalance challenges. Addressing the imbalanced nature of the data required a two-pronged strategy. Beyond weighted loss functions during training, the researchers implemented post-hoc threshold calibration to maximize performance on the underrepresented subjective class. The multilingual aspect presented interesting trade-offs between language-specific fine-tuning and cross-lingual knowledge transfer. Surprisingly, they discovered that excluding Arabic from multilingual training actually improved overall performance, suggesting language-specific challenges in sentiment subjectivity relationships. Let's examine how these design choices translated into measurable improvements. The sentiment augmentation approach delivered measurable improvements, particularly for detecting subjective sentences in English and Italian. These gains validate the core hypothesis while revealing that the effectiveness of sentiment signals varies significantly across languages. Comparing different model architectures revealed interesting patterns about what works for this task. While BERT-style models with sentiment augmentation performed well, larger language models like Llama didn't automatically translate to better performance in this constrained setting. In the CheckThat 2025 competition context, their approach showed promising generalization capabilities. Despite a submission error affecting their multilingual results, achieving first place on Greek zero-shot evaluation demonstrates the method's potential for unseen languages. The results revealed deeper patterns about how sentiment and subjectivity interact across languages. The analysis revealed that subjective sentences tend to carry more emotionally polarized language, especially negative sentiment. This pattern was most pronounced in English, explaining why sentiment augmentation provided the strongest improvements for that language. Arabic presented unique challenges that highlight the complexity of cross-lingual sentiment analysis. The weaker correlation between sentiment and subjectivity in Arabic suggests that cultural and linguistic factors significantly influence how opinions are expressed in different languages. The researchers identified several areas for improvement and future exploration. The work acknowledges several important limitations, particularly around the domain gap between social media sentiment models and news content. The simple concatenation approach, while effective, likely doesn't capture the full potential of sentiment subjectivity interactions. The research opens several exciting avenues for future work, training sentiment models, specifically on news data, and exploring more sophisticated fusion mechanisms, could further improve the approach while expanding to richer emotional dimensions. Let's consider the broader impact of these findings for fact-checking and multilingual AI. This work has direct applications in our current information ecosystem. News organizations and social media platforms can use these techniques to automatically separate opinion from fact, supporting both human fact-checkers and algorithmic content curation systems. This research demonstrates that thoughtfully combining multiple AI signals can enhance performance on nuanced language understanding tasks, even when those signals come from different domains. The key insight that sentiment and subjectivity are linguistically intertwined opens new possibilities for multilingual content analysis. To explore more cutting-edge AI research and stay updated on the latest developments, Visit emergentmind.com.